Good afternoon, everyone. Welcome to this session on accelerating time to value in data analytics. I'm Gerard Cowburn, a senior solutions architect at Amazon Web Services in our global financial services practice. With me today are two colleagues from Goldman Sachs, Ram Rajamoni, Vice President and Tech Fellow in Data Engineering, and Francesco Pontrandolfo, Product Manager for the Goldman Sachs Financial Cloud. Thank you all for joining us here today, and congratulations to making it to Thursday afternoon at re:Invent. Today, we're going to take you on a journey of how Goldman Sachs informs their investment hypotheses, blending together diverse hybrid sources of data seamlessly to deliver insights and accelerate their time to value. We're going to do a quick introduction to who Goldman Sachs is and set the context of their data-driven investment process. We're then going to double-click on the architecture underpinning Goldman Sachs Financial Cloud, and we're going to look at a few key factors that enable it to deliver high-speed, low-latency, real-time analytics on complex financial market data. We're then going to look at some key data sourcing integrations underpinning and powering the analytics within Financial Cloud. And we're also going to take a look at the open source Legend platform and how that also helps accelerate time to value by optimizing data engineering operations with a consistent approach to data modeling and wrangling. And then finally, we're going to bring it back all together to show us the kinds of insights that can be achieved by blending these technologies. And we're going to share some of the lessons learned from across this journey to help you all accelerate your own journeys as you progress out of here today. So to kick us off, I'll pass over to Francesco to introduce us to Goldman Sachs.
Thanks, Gerard. A few words about Goldman Sachs. Probably many of you already know what it is, but so we are a global financial institutions. We have a broad range of clients, ranging from retail through our markets business, corporation to our transaction banking, but also we have institutional clients such as large asset manager and hedge funds. Time and speed are kind of two key factors the organization always tries to optimize for, just because they are essential to be competitive in our industry. To do so, we do a significant investment in technology. A large percentage of our workforce is actually our engineers, and they are scattered throughout the organization. For instance, I sit in global markets. I'm a product manager. I deal with engineering focus on global markets. Global markets is the division that essentially works with clients, institutional clients, and help them manage risk in different ways. Ram works in the core data engineering team, is responsible to bring in data within the firm and make sure that everybody can access data at any speed to fulfill their use cases. But obviously, there are many other personas. We are risk managers, portfolio managers, traders, quants, and strats. What they have in common that everything that they do really depends on data. We use data every day to drive business outcome, investment decisions, and so forth. Let's look at an example here, for instance, where someone in research or a portfolio manager wants to test an investment hypothesis. Investment hypothesis such as there is such a turn in terms of moving to green energies, and probably you may think of that renewable companies may outperform the market because obviously there can be more investment in the specific segment. So someone that wants to test the hypothesis, what they have to do, right? First thing, you want to get your compute applications that you are intended to use. Second step, you want to start getting some data. Data sourcing, typically you either look outside, and so you look at a catalog across different data vendors. They may be of interest. You want to license the data once you get the data in. And then you can also augment with internal data sources that are available throughout the organizations. Once you get the data, you identify the data that you want to bring in. Obviously, there is a process of normalizing, cleansing data so that you can have data that you can rely upon, right? You don't want to start the other phases without trusting really the data that you're bringing in. Once you do that, you also need to make sure that all different data sources are kind of normalized and mapped to a consistent data model because you want to simplify access to the data itself. So now you have compute, you have data. What do you have to do next? Next, you start really formalizing your investment hypothesis, and you want to create a model just a mathematical representation of your hypothesis. To do that, you use the raw data, you build factors. Factors is just simplified representations. They actually can relate to, you can apply formulas and algebra to it to kind of define investment strategy. Typically, you will run optimization tasks to build different portfolios and construct the strategy and the assets that you want to include. You do some backtesting, validate, make sure that actually the strategy accomplish what your intention on and achieves your objectives. Once you do that, probably you end up with variations of the strategy that you want to further test and compare, accessing other type of parameters and metrics, and also run some sort of stress scenarios and to make sure that actually the strategy is robust enough and can withstand different market conditions. Once you've done that, you're happy with the model, we're going to go into the last phase, which is really productionizing the model. What it means is that now you want to be able to integrate real-time data because you want to be able to track and monitor risk for that specific strategy so that you can act upon it, hedge some of the risk that you see coming depending on the market is turning, or even execute trades. Seems pretty straightforward, right? It's probably a common process across many research type of efforts. But in reality, obviously, there are some challenges. That's why we're here. And so first and foremost, there are intrinsic challenges with the financial data. What I mean by that is that financial data is really always evolving. There are always new instruments, new asset classes that are coming available. Think about digital assets or cryptocurrency, for instance. And in addition to that, there is always corporations, for instance, they are corporate events that will impact the way the instruments trade. So there are mergers and acquisitions, IPOs, dividends, and stock buybacks. And all these actions actually introduce some breaks in your historical data, and you need to be able to handle that effectively so that you can always have clean time series data on top of which you can build, backtest, and validate your models. In addition to that, there are challenges related to the breadth of data sources that we see come into play. Again, more complex data, and with breadth also comes the other challenge within the structure of the data. There are different semantics, different data models. Quite often, different vendors have a different way to describe data. So it's up to the consumer to reconcile and disambiguate some of the overlaps that can be across different data sources. In addition, you have different distribution mechanisms. There are more traditional ones, such as file transfer or fixed messaging. But also with cloud, we see S3-based type of file sharing, Redshift as a way to share data via Redshift data share, and so forth. And then in streaming, different PubSub mechanism, bespoke API to be able to source data in real time. So in this context, last year we actually announced GS Financial Cloud, right? The ambition and the objective is actually to accelerate time to value by helping internal clients, internal stakeholders within GS, but also external clients, to be able to streamline the process and remove the undifferentiated heavy lifting of sourcing, managing, and analyze financial data. You can think about Financial Cloud as a modular set of services that can interplay with each other. But essentially, they're trying to address the issue of data curation, data management, and data analytics. Data curation, you can think about as a data service that allows you to access GS proprietary data. These are data sets, data points that our trading desks generate every day. They use every day to conduct the business, but also we make available to our clients to be able to access. At the same time, there are a wealth of third-party data sets that we source across many vendors out there, and we add on top the layer of a curation layer because it's the same data that we use every day to conduct our business, and that curation is kind of the value add that we add on top of the third-party data. All the data sets, they come unified to a consistent data model, so it becomes easy to access and navigate across different data sources without worrying too much about differences across all the vendors and the GS data. And as well, they are all linked together using a common reference data database that allows you to link data sets very easily. This is great. Now we have GS data, we have third-party data. Clients, internal teams, they ask us, hey, by the way, I want to have my own data as well. I want to augment with your analysis, my analysis, with also my view of specific asset classes, my prices, whatever, right? So what we did, as of this year, we actually launched the ability to spin up compute instances on the GS Financial Cloud. What it means, compute instance really comes with a fully managed time series database that allows to ingest your own data, mesh and enrich the data model that we already have in Financial Cloud with bespoke data points. Even the data that clients and internal teams may access, they all get mapped to the same security master, so for easy integration across the different type of data sets. And lastly, the analysis, right? So you have all the data, you have GS data, third-party data, your own data, and now you want to analyze the data. How you do that? Well, we make available REST endpoints where you can access for data access, the distribution, and as well, we created a Python SDK that we open source. It's called GS Quant that allows you, besides accessing data into a Python-friendly environment, like Jupyter Notebook or any Python dev tool that you can think of, but also as a rich set of functionality to do backtesting, risk analytics, and time series analysis. We also have from a low-code, no-code perspective, a data visualization tool and data manipulation tool called Total Pro. Even this one is a tool that was built in-house, and we are externalizing the service to our clients, where they can interactively manipulate and work with time series data. Everything, again, to be able to serve a multiple type of constituency that wants to use our tools. Okay, now let's look what we did and how we implemented GS Financial Cloud on AWS. This is kind of the high-level architecture, the key components that we use throughout the system. I'm going to go through each box, starting from the left. It's our perimeter account. It's really where a user will come in, the request will come in. We do authentication, authorization. We also do a first set of validation to make sure that the clients have access to the correct endpoint, the right endpoint. We use all web tokens for authentication. So the request will come in, and suppose you want to request some data from Financial Cloud, you're going to hit our managed data service, which is the account in the middle of the architectural diagram here. What it does, the managed data service will pretty much collect the request and will serve the request, looking up the securities and indirecting the request back to the data layer where we collect the metrics and return back to the client. We use ECS, of course, to scale depending according to load. We also use DynamoDB in an interesting way to be able to link internal identifier and map to the common identifier typically used when requested data in the financial space. And as well, Elasticache to optimize the performance of the query. And as well, on our web application, we use OpenSearch to enable textual search, such as looking for data sets, searching through the schema, searching for fields. Every time the request comes in, obviously, in the financial services, there are a set of canonical identifiers that typical assets are mapped to. And that's what I was referring to, the common reference data layer available in Financial Cloud. And that will hit our SEC master account. It's what you see on the top, on the first row, where pretty much we map reference data, we maintain, validate every single instrument, and also we maintain this mapping across this canonical symbol. Suppose now, for the data management side, what do? You come in, you want to spin up a request. What you would do, you will hit the cluster management service, which is the account on top, last column on top right corner, which is really the control plane to be able to provision and monitor infrastructure in Financial Cloud. We use ECS again deployed on Fargate, really simplified our life in terms of managing and scaling up the service. We use CloudFormation, kind of stores the blueprint of what the instance looks like when it gets deployed. And also we use step function as kind of the core for orchestration to manage the entire process of provisioning, monitoring, but as well patching the AMI and also the container images. And then you see on the bottom kind of every single instance of the time series database that you spin up. Every time series database is kind of isolated in a dedicated account to remove issues around nosy neighborhood and provide isolation and privacy. Every account is encrypted using KMS keys, custom KMS keys. And overall, across all the accounts, we use every connection is via VPC endpoints and private links. And as well, we use MTLS for encryption in transit. All right, why don't we dive deeper a little bit more into the time series database? Because it's one of the key components and where fundamentally define the data plane in financial cloud. Before doing that, let's recap a little bit the issue of challenges associated to financial time series data. Typically, you have to deal with sparse timetable. There are data sets that have frequency, monthly frequency, daily frequency, but also you can get down to a resolution of nanoseconds for high volume, high density type of data. You need to be able to, typically you want to be able always to access most recent data in a very low latency fashion because those are kind of the really data that matters. When, for instance, markets are turning, you want to be able to access that very fast, very quickly. Second piece, you need to be able to manage this bitemporality concept, so that you can always track changes that I mentioned earlier that often happen on top of the financial data, and so that require idempotent updates. And the last piece, because there are always corrections and revisions applied to fundamental estimates or what have you, you need to be able to manage out-of-order backfills on top of the data. So what we did, throughout the years, we built our own custom time series database. With GS Financial Cloud, actually, we moved that from on-prem and refactor and optimize to run on AWS and take advantage of flexibility and elasticity that cloud provides. So and if I want to describe a very high level the architecture, so we have these three-tier storage layers to be able to handle the different type of data. So in memory for the most recent data, SSD type of storage for medium term, and then everything else get deployed into cheap storage solution that allows you to store infinite history. Also, the system is built in a way that allows you to bring data from any of the storage layer up in memory to do a fast processing calculation. So what it looks like on AWS, every single instance is really a collection of nodes. All nodes, they work in parallel, and they replicate data across every single node to make sure there is resiliency, maximize availability for every single service. That's fundamental when you're trying to support live application like trading or risk monitoring as well. Every single node has a different set of processes to be able the entire flow of data. So there is a collector that will collect data and reformat and run quality checks. Loader will ingest data into the corresponding storage layer. There is a replicator process that makes sure that all the nodes actually have the same data at the same time. And lastly, we have a tick server, which is the process responsible to provide back the data and run analytics, server-side analytics on top of the data. So obviously, we deploy across multiple availability zones to maximize resiliency. We use EC2 in memory for the most recent data, EBS for SSD type of disk storage, and S3 for the infinite storage layer. We use for Prometheus, manage Prometheus for telemetry and monitoring, and also I already mentioned about KMS, custom managed keys, for encryption arrest. Okay, so that's kind of overview on GS Financial Cloud. Now I think it's a good time to see how all everything comes together, and to do that, I'm gonna pass it back to Ram, that's gonna go to end-to-end a real-life example.
Thanks, Francesco. How are we doing on time? Are we doing good?
Yeah.
Excellent. Okay, so let's just do a little bit of a recap. We had Gerard introduce the topic. We had Francesco talk to us about GS Financial Cloud for data, and also talk to us about the time series database that underlies the whole construct. So this must all be a little abstract, so we want to bring it down into the concrete. And to do that, we're going to take a topic which is extremely topical, environmental, social, and governance, or ESG, coupled with decarbonization commitments and objectives, kind of put that all together into a kind of a use case, and see how GS Financial Cloud for data can actually help with that. Now, in this space, there's a ton of questions that people ask when this topic comes up. So let's dive into some of those. If, as an organization, or even as a government, there are a lot of climate policies that are constructed. And these climate policies impact both corporations as well as investors. At the same time, you have corporations, investors, states, and utilities making commitments, having objectives, and all of these impact fund flows into different kinds of funds. All of this activity, which happens all the time, gives rise to trends, and these trends are across global markets. So you want to know what these trends are like. And lastly, given this very complex world, what kind of advice can you give to both clients and investors on how to thematically work in this space? What kind of things to invest in? Where do we see investment opportunities? So it is that problem that we're going to try to take a piece of and work out today to some extent, yeah? So let's kind of dive right into it. This kind of picture illustrates what we're going to try to do today. On the left-hand side, you'll see us getting environmental, social, and governance data, ESG scores, from the London Stock Exchange Group, LSEG, or Refinitiv. Coupled with that, we're going to look at decarbonization objectives and commitments from Transition Pathways Initiative. This data, which we call reference data, is going to be coupled with real-time market data, or pricing data, which is what you see in the lower left corner. This is going to get flown into Financial Cloud, Goldman Sachs Financial Cloud for data. And then from that, we're going to apply our tool, GS Plot Tool Pro, which is the Goldman Sachs original time series analytics tool. It's perhaps the most popular application on a trading platform. And we're going to show how that can be used for doing bespoke visualizations as well as analytic operations. Now, I should mention at this point in time, there's two other ways in which people use the data that comes into Financial Cloud. One of those happens to be a richly entitled set of APIs, REST APIs, and you can go find them at developer.gs.com. We also provide a Python toolkit that's been open sourced called GS Quant that allows people to work with developers and engineers to work with and come up with different strategies, different kinds of analysis that they can do in the space. Risk management, for example, is one of the things that you can do with GS Quant. So the topic we're going to talk today is to cut a diagonal from the top left to the bottom right. Look at this data going through, and then as it flows through, what that looks like when looked at using Plot Tool Pro. Let's dive a little bit deeper into that. As I mentioned earlier, the London Stock Exchange Group Refinitiv Environmental Social Governance ESG scores and the Transition Pathways Initiative decarbonization objectives and commitments, those are what we call reference data. So let's talk about how this data kind of comes into Financial Cloud, how we bring it from where it lives into Financial Cloud and work with it. I should mention one thing up front here, which is that through the course of this, you will see some example portfolios. Those are just examples purely constructed for the purpose of illustrating the methodologies and tools that we have put together here. Those are not actual portfolios that you can work with or do anything with. Those are just examples for the purpose of the talk. Great. Let's dive into it. The journey starts with data. at the beginning, we had Francesco talk about how in this space, it's all about data that is used for analyzing problems that happen. And in our case, it starts with AWS Data Exchange. This is a place where you can discover and access third-party data. There's close to, 4,000 data sets that are now available in AWS Data Exchange that you can discover, search, find, and then subscribe to. And this subscribed data is then delivered in many ways, two of which we benefit from, one being object-based and the other being table-based delivery. And this particular screen grab that you're seeing is a view that we in Goldman look at when we look at our view of the ESG part delivered to us by the London Stock Exchange Group, Refinitiv, for the ESG scores. You'll see hopefully at the top, you'll see some data given to us as objects, and at the bottom, you'll see some data given to us as tabular forms. The object data comes to us in S3. Tabular comes to us through Redshift data sharing. A lot of talks yesterday, day before on Redshift, right? Great. So once we have this data, what do we then do with it? Let's first begin by looking at some of the raw data. The ESG score information we get happens to be delivered through a number of tables. And in the screen up there, you should see two of them. And even there, I'm only showing some of the attributes. Some of the data is masked for privacy purposes. Two things in particular that you see there are the anti-competition score and the business ethics score, which are both part of the ESG data set that the Refinitiv group gives us. Along with that, you'll also see organization IDs, and the table on the right-hand side kind of connects this organization ID to the central index key, SIC key, as well as the legal entity identifier. So this is how the producer, in this case, Refinitiv, gives us the data. As must be evident when you all work with data, this is not the medium in which we like to work with the data. Right? We prefer to work with it in different forms. In fact, what we show below is the form in which we like to work with the data. So the difference between the top and the bottom is the top is a disparate set of tables. The bottom has semantic meaning that is very specific to Goldman. In particular, it connects together organization names, the LAI, or legal entity identifier, the different scores we care about, and maybe even some grades that we might assign based on logic we perform on top of those scores. So this actually begs a couple of questions, right? The first question that it begs is, how do we kind of transform this data from the form that it lives in into the form that we want at the bottom? And again, let's take a step back to see why we want to do that kind of formulation. It's because the data at the top isn't strongly typed. And second, the form in which it is at the lower part is more convenient for us to work with. So this transformation needs to be expressed in some form. And in addition to expressing this transformation, you want to then execute this transformation and transport the data from the AWS Data Exchange into the time series database that Francesco talked about earlier. Right? So this is a good time to again do a level set. What did we talk about? We had GS Financial Cloud, the architecture, time series database. We're talking about a concrete problem. We want to bring in ESG scores, decarbonization data, as well as real-time market data into Financial Cloud. We have the data, the ESG scores, but not in a form that we like. We want to somehow convert it and transport it, bring it into Financial Cloud. Let's talk about that architecture first. This is what it looks like. At the top, we have AWS Data Exchange that's giving us data in both tabular form on the right-hand side and on the left-hand side, and object form, Amazon S3 on the other side. That comes into, and we do our processing using an Amazon managed serverless Spark environment called AWS Glue. This is a service that we like using because it spins up the environment on the fly, does the work, tears it down. That's the serverless part of it. And it's managed, so the overhead that we have to work with it is minimized. On the Goldman side, we can work with what we care about, while the heavy lifting infra is left to the AWS side. Now, you'll see on the right-hand side of the picture, the secrets manager and the federated identity provider. These exist because that is what we use to connect to the Financial Cloud through the APIs and the connector that you see there, the GS-FCD connector that you see at the bottom. That's how we connect to Financial Cloud. The OAuth token that comes from the identity provider is what we use to talk to Financial Cloud with through its APIs to write that data into the time series database. On the left-hand side, you'll see Lambda, and the Lambda is what we use to kind of trigger these pipelines, this ETL that happens from the AWS Data Exchange into Financial Cloud. And then you'll also see an S3 bucket. That's where the assets live. If you kind of think for a second, I talked about how the form in which the ESG data comes in isn't really amenable to how we want to consume. That transformation, the logic for that lives in the S3 bucket, along with the script that actually runs the pipeline. The logs, of course, all get dumped into CloudWatch. Right? This is like a little picture of what our architecture looks like for the transport part of things. What I haven't talked about is the box kind of in the middle, the little brown box in the middle called the legend connector. And legend is the part that actually lets us decouple the form in which the data is given to us into the form in which the data wants to be consumed, or we want to consume it. Legend is an open source project. I believe Goldman open sourced it about 2 years ago by contributing its code into the FinOps Foundation. And it lets people easily collaborate and work with data. This is something you can all pick up and download and work with right now. It's a way to work with data at the semantic level. GitHub.com has the code, and there's legend.finops.org where you can go to get more information about it. Again, why are we talking about this? It's because we have the data in a form that the producer has done. We want to consume it in a form that's more amenable to us. This notion of working with data in a form that's amenable to us is best illustrated perhaps by just saying that we want to work with data like engineers, we work with code. For example, when you write a program in a high-level programming language, you don't worry about register allocation. You let a pre-created construct, the compiler and the assembler, work with it. And you let that take care of mapping it down into the actual hardware. You work at a higher level. That's what we do. Same thing with data. When you work with Legend, Legend lets you work with data at a semantic level, which means you express data models and transformations in a functional, immutable language called Pure, also open source as part of Legend. And by doing that, you let the platform, the pre-created existing platform called Legend, worry about compiling that down into the actual implementation specifics. So in the case of ESD scores that come to us through Redshift, we don't worry about writing Redshift queries to work with the data. We express the transformations in this pure language and the models for converting it from the form the producer gives us, Refinitiv, into the form we want. Compilation takes care of actually creating the SQL queries, the joins, all that kind of stuff. And it is this way of kind of lifting the conversation into the semantic layer that makes a lot of sense, that gives us nimbleness. In addition to just pure nimbleness, there's a couple of other kind of obvious and some not so obvious advantages we get. Nimbleness gives us not just latency nimbleness. You can quickly adapt when the producer changes the form in which the data comes, or you find a new need for how you want to consume the data. The nimbleness also lets the same sized team work with more data. In the ESG space, as well as in the reference data space, there's tons of producers, tons of different kinds of data coming in. If you want higher quality insights, you want to bring in more data. So this lets us have the same size team work with larger scopes of data, bringing them into our world, into Financial Cloud, so that you can then derive better insights, faster insights from it. So this cycle of data discovery, data exploration, understanding what's going on, talking to one another in that business semantic level, and then publishing it, and then working with this governance, all of this together constitutes what the Legend data management, data modeling, and the data API platform. So I used a lot of big words there: data management, data modeling, data API. Let's kind of, again, come back into the concrete by tying it together. Several takeaways from this slide. And I promise one of them isn't the font size, yeah? You don't have to read it. So reference data, by its very inherent nature, is complex. The financial space deals with complex data that is heavily, intricately intertwined. And this picture kind of illustrates what's going on there. This is from the ESG score data that we are working with. There are two kind of screen grabs there. The one behind kind of shows you the organizational ID and how that maps into different identifiers. The one in the foreground shows just how the ESG data is tied together. None of these pictures are done by humans. It's machine generated. The business person working with the data modeler, the data steward, works with data at the abstract level, in the pure language inside the Legend world, in Legend Studio, which is the IDE, where this was done. And then the system generates these pictures, these diagrams that can be used to derive more insights and do more things with the data. So again, let's pause for a second. We talked about having ESG scores, and we talked about how the data is going to be brought inside Financial Cloud. We talked about how the transportation for that happens through AWS Glue, managed serverless Spark environment. We talked about how that is actually expressed in this platform called Legend, and how that actually gets done. Now, I began this entire segment by talking about how we want to work with data like we work with code. And one of the cool things we like about working with code is the REPL. And to some extent, this is the data REPL. It is the Legend query aspect of the Legend IDE, which lets you work with data in a very intuitive, REPL-like manner. I want to make a change. I want to test it out. I want to query it. I want to make sure it's OK. Get that thing completely refined and done, nimble, faster insights, so that it's all ready for taking it and transporting it into the world that we want to deal with. So a ton of things we talked about. Let me kind of recap and tie that all together with this kind of picture that illustrates how the whole thing works together, right? The first part is we want to start with AWS Data Exchange. The data comes inside Data Exchange. We consume it in either tabular form or in object form. Some providers prefer to give us in tabular form. A lot of providers give us data today through FTP and other mechanisms. They prefer the object form of delivering data. No matter what, we couple them together into one pipeline, which is what you see here in the middle. And it is the Legend query that that I showed in the previous slide that we use to work with this data, make sure the data is actually in a form that is suitable for kind of bringing down into the Financial Cloud. Because once it's down there, fast insights can now happen. Now, there are certain aspects in Legend, like persistence and other grammar constructions that we haven't talked about here today that let you express this data movement. Those are all used. These are all compiled down. Those end up becoming the Glue pipelines. And these Glue pipelines are what are then done and worked to bring the data, transported data down into Financial Cloud. Now, once it's in Financial Cloud, we can verify that the data looks the way we want it to look like by running these analysis using Plot Tool Pro or using the open source Python toolkit, GSQuant, if you want to do richer kind of risk management or other solutions. And then also you can do that using these APIs. So just look at the raw data, right, from developer GSCOM. So the last part that we haven't talked about is the right-hand corner, which is the real-time kind of market data, how we bring that into the Financial Cloud. Once that's done, though, a practitioner would use Plot Tool Pro to work with this data, bring it all together, and do interesting things with it. That last part of bringing in real-time market data, which happens to be on-prem, just to add another level of complexity here, the reference data comes delivered to us through cloud. The other data comes to us on-prem. We have to get it out into cloud to work with it. I'm going to bring in Francesco to first talk a little bit about the reference data part and what that kind of looks like in Plot Tool Pro, and then talk about the market data part. There you go, Francesco.
Thank you. Yeah, so going back to the initial discussion, right? So we use the reference data, we build factors, we have a bunch of strategies. Now they want to compare and analyze. In this case, that's what we're achieving here. We have a bunch of line charts. We are comparing different type of ESG strategies with each other. Again, these are kind of simulation portfolios that we're using just for the purpose of the talk here. The idea is that with Plot Tool becomes very easy to down deep to the data layer, source different metrics, bring it up, and do a visual analysis for faster feedback and action on top of that. The last piece is, again, productionizing. Let's say that from the previous chart, we decide, hey, we really like this strategy. Now we're going to move in production. We want to start tracking and monitoring so that we can drive our investment decisions. So we do that by bringing data from using, again, LSEG Refinitiv. There's a product called Electron. Electron is a solution that streams real-time data. It's broad coverage. There are about on a daily basis, 7.1 billion shares are captured through the product. That equates around 10 million updates per second or events per second that we register and we bring in across 150 different global markets and execution venues. What it looks like the process today. So there is a bespoke custom API that makes available. We source the data, we bring the data into our Tiger plant that sits on-prem. And then we have a collector process that will run quality checks on top of the data. We push the data up to the cloud via direct connect connection. We have a transit VPC type of architecture to move data into dedicated instances of our time series database available in financial cloud that we saw before. Again, here, private links and VPC endpoints to secure connection through the AWS backbone, and also a mutual TLS for encryption between on-prem and cloud. This is what the results will look like. Now, in this chart, actually, I have some of the same strategies that I had in the previous chart, but now everything is, I'm actually graphing tick data coming from directly from the Electron data directly into our platform. Again, here, plot tool is just a way to process data. We have a rich library of server-side analytics to be able to process and analyze even a petabyte scale historical data to fulfill use cases such as market structure research, so really understanding how the market is behaving and different events occurring, and also things like transaction cost analysis, so that you can perform how your trading activity is measuring and is penalized by accessing the market at the wrong time, for instance. All right, so we are close to the end, so we can do a quick recap on challenges and some of the lessons learned. So on the left-hand side, some of the challenges that we see. So the breadth of data and the number of data sources and data type, it's increasing. I don't think it's going to slow down. We will never slow down. And with that, also the complexity of it will become in more and more. We see different needs of different type of data, from structured, semi-structured, unstructured data that now are needed to be brought in to be able to drive investment outcomes or to manage better risk. And as well, data becoming increasingly more complex. We saw the slide that ran it up with ESG score, simple in principle, but requires joining a lot of different data to make sense of it. The last piece, if you want to use real-time data, you need to have a system to be able to stream data directly into the platform. Otherwise, the size of data will be impossible to manage kind of on an offline batch process. And to go fast, sometimes you need to compromise and be able to mesh data on systems that are already working and functioning. And so you want to mesh data about on-prem, data sitting on-prem, or data sitting on cloud into one single point to simplify access. George, you want to cover some of the...
Yeah, sure. Thanks, Francesco. So I think we've heard a lot of challenges and complexity throughout this talk, right? And I think there's a few key enablers that cloud provides which help us solve for these. The first one, as Francesco has just mentioned, is that data is ever increasing. You know, it gets broader, it gets deeper, it gets more complex. And trying to keep pace with that on-premise is just incredibly hard, right? You do a lot of what we call undifferentiated heavy lifting, CapEx cycles, buying new hardware, doing upgrades. With cloud, you can kind of ignore all of that, right? You get much more scalability in the storage infrastructure, you get much more scalability in the analytics infrastructure, and we can take care of most of the kind of hard work and scaling activities that go on there. The second piece is that cloud increasingly provides a common platform where partners, vendors, customers can come together to share data seamlessly in a well-governed, secure way and real time. And I think one key lesson from this journey is that the more that we can work together to build this ecosystem, to build this community, the more successful we'll all be as a collective. And then the third piece, tied into the just burden of managing, you know, this scale of on-premise infrastructure that this kind of analytics requires, is that the higher up the management stack you can move. We've heard Ram talk about AWS Glue. They're no longer managing Spark clusters and trying to spin them up and patch them and version upgrade them. Moving to managed, particularly serverless technologies, you can kind of ignore the operational burden, a lot of the capacity management burdens, and you can really focus on what differentiates you. You can build the cool tools that we've heard presented on the stage today and maximize the unique value that your business actually has and brings.
Yes, definitely on the cloud side, for sure, the idea of simplified democratization and democratize the data across the organization. So we have an extensive catalog, easy to browse, easy to navigate, to be able to access and discover data very simply. Also think about scale. So obviously you want to use the right tool for the right jobs. That's why when you start going to the high frequency, deep history time series data, you want to use a time series database that optimize to actually process and analyze the type of data. And also for us, it's very important to be able to scale. Markets can turn very quickly, and so you want to be able to have the compute power that goes up and down depending on market events and how the workloads will scale. Ram, you want to talk about more about
Sure.
how you operationalize?
I was thinking about how engineers love to build things. And the question really is, what should engineers be building? And what serverless and managed infra lets us do, it just lets us, Goldman engineers, work on the financial part of things, work on things that actually solve the high level of the stack, while we let the infra be done by the AWS team. So that's a huge, huge, huge benefit for us. Second thing, and this is rather counterintuitive, by paying the cost up front, and that too using a platform that allows you to do it very easily and simply, especially in working with complex financial data, things like reference, lineage, data lineage, and ontology kind of get baked into the system. You get them for free, while at the same time you're nimble and lets you get high quality, faster insights as you go. And last but not least, we mentioned how in this example we're bringing together two kinds of data, data from the cloud and data from on-prem. And when we bring data from on-prem into cloud, there are a lot of considerations that we have to go through. Risk especially, right? Risk mitigation, we have to do that in a risk-managed manner. Those conversations have to start really early and be done in a very thorough and detailed way. AWS helps us. But the engagement early is a lesson that we learn, because barring that, things don't come out at the right time.
All right.
Cool. So hopefully that's given you all some good insights into the challenges that we face, the solutions that have been put forward. For anyone who wants to learn more, we're going to be taking over the Capital Markets Lounge area in the Financial Services Lounge in the Caesars Forum main hall, just around the corner here, immediately following this session through till about 4 p.m. today. So please come and stop by there. If anyone doesn't get a chance to do that, I know there's a lot of sessions, a busy schedule. Goldman Sachs do have a booth 3446 in the main expo hall. So again, do feel free to stop by there and have a chat with the experts. Thank you all for joining us today.